Hello everyone, my name is Arohi and welcome to my channel. So guys, in my today's video we will perform vehicle and pedestrian detection using YOLO-NAS algorithm and Kitti dataset. But before moving to the practical implementation, let's understand why vehicle and pedestrian detection is important. Then we will discuss about the YOLO-NAS algorithm and the Kitti dataset in brief. After that, we will make our vehicle and pedestrian detection application. So let's start. So vehicle and pedestrian detection are critical components in the development and deployment of autonomous vehicle and smart city applications. These technologies enable machines to recognize and respond to the presence of vehicles and pedestrians in their environment, ensuring safer navigation and interaction with the urban settings. Okay. So in the context of autonomous vehicle, the vehicle and pedestrian detection systems utilize a combination of sensors, cameras and AI algorithms to accurately identify and track the positions of other vehicles, pedestrians, cyclists and other potential obstacles on the road. So this information is crucial for autonomous systems to make informed decisions about speed, directions and when to apply brakes, among other actions to avoid collisions and ensure the safety of all road users. For smart city applications, vehicle and pedestrian detection technologies are employed to enhance urban infrastructure and traffic management systems. By integrating these technologies into the traffic light or surveillance systems or other urban infrastructure, cities can monitor and analyze traffic flow, and they can also analyze the pedestrian movements more efficiently, right? So this enables smarter decision making regarding traffic light timing adjustments, congestion management and then the optimization of pedestrian crossings. Okay, so this all ultimately will lead to a improved traffic efficiency and pedestrian safety. So that's how this vehicle and pedestrian detection application can be helpful. So now let's talk about the algorithm, YOLO-NAS algorithm. YOLO-NAS is a state-of-the-art real-time object detection model developed by DCAI. So this YOLO-NAS model is generated by DC's AutoNAC neural architecture search technology, and this model stands out among all the object detection models available in the market by offering the best trade-off between the accuracy and latency. So this YOLO-NAS surpassing other models like YOLO V5, YOLO V6, YOLO V7 and YOLO V8 with its unbeatable accuracy and speed combination. Okay, so we can see in this graph over here, you can see that all versions of YOLO-NAS, which is small, medium, large, with quantization and without quantization, achieves good accuracy. Also, you can see that the map value is increased as compared to the previous SOTA model, which is YOLO V8. Alright, and guys, the use of NAS is one of the secret sources to the success of YOLO-NAS, as none of the previous YOLO family of models were generated by it. And the other factors that make YOLO-NAS the fastest object detection model to date are its quantization friendly basic block. So what it is YOLO-NAS introduces a new basic block that is friendly to quantization and which address one of the significant limitations of the previous YOLO models, and they can go to 8-bit easily without losing a lot of accuracy. Also, YOLO-NAS leverages advanced training schemes and post-training quantization to enhance performance. So these are the reasons that's why I've decided to work with this YOLO-NAS today. And now let's see the dataset. Now type Kitti dataset and then open this first link. So this is the Kitti dataset website, and Kitti dataset is a popular dataset used for computer vision tasks, particularly in the context of autonomous driving. And guys, since its release, Kitti has become one of the most cited and used dataset in autonomous driving and computer vision research. and this dataset is collected from a variety of urban, suburban, and then highway environments, offering a broad spectrum of real world scenarios. And this diversity helps in training models that are capable of operating under different settings and conditions, which make them more versatile and reliable. Okay, and this Kitti dataset include detailed annotation for vehicles, pedestrians, cyclists, and some other objects in 3D and 2D format. We can perform 2D object detection, 3D object detection, we can perform tracking, we can perform lots of this computer vision task using this dataset. And if you want to see the dataset, so first, just before showing you the dataset like 2D and the 3D dataset, let's click on this setup. If you'll click on this setup, you will see the the entire setup of the car on which they have collected this data. And you can see over here the sensor setup, all the sensors and their details have been mentioned over here, and what all things they have used to set up this car to collect the data. All that sensor setup detail you can see on this page. Okay, and this over here you can see this stereo, flow, and depth, what all these things are. This is just you can say that this Kitti dataset include a variety of data types. Okay, so we will talk about that also in a minute, but for now just see this object. Under this object you can see 2D object, 3D object, and then the bird's eye view. What it means is that you can work with it has 2D data object annotations, 3D object data annotations, and the bird eye view. Okay, now for our today's problem, we are performing object detection using YOLO-NAS, which is a 2D object detection model. So for that we will go to this 2D object, and you will be redirected to this page. Okay, and on this page you can see this first link, download left color images of object dataset, which the size is 12 GB. We will download this file, and how you can download it, just click on it and this download will start, and you will get a zip folder inside your downloads folder. And to download the training labels, you will click on this link, download training labels of object dataset, and the size is 5 MB. When you will click on this, you will get a zip file inside your downloads folder. Now let me open the downloads folder and show you where this file is. Okay, so let's go to the downloads, and here you can see this one, this one. Okay, these are the images, and I have unzipped it, and this is the folder, and this is the other folder, the training labels, and after unzipping it, this is the file. Now let's open these folders one by one and see what all things are there. So first I'm opening this training folder, images folder, data object image folder. Inside that you will get two folders, training and testing. And let's open training folder. Inside that you have one another folder, and inside that here you can see all the images. So we have 7481 images, training images. Let's open one image and see. So these kind of images you have. Okay, training images. Now let's go back and go to this testing. Inside testing we have test images. Okay, so we have 7518 test images. So guys, this is how these are the images. Okay, now let's see their corresponding annotation files, text files. Okay, so for that we are clicking on this label folder, and inside that, see guys, here you can see that we only have training folder. Under images we were having two folders, training and testing, but under label we are only getting the labels of training dataset. Now let's open it, and you can see we have 7481 annotations which are in text format. So we are not having the annotations for our test files, and we have this annotations for this training data only. Now let's open one of the annotation file, and let's try to understand what kind of values we have in it. Let's open this annotation file. So this is the first annotation file, and this is the class name, and then we have these different values over here. Now let's understand what these values are. So guys, each line in the annotation file describes one object in a scene. So in this text file we have only one line. That means there is only one object in this image. So suppose if you have an image which have three different objects, then you will have three different lines, and one line will give you the information related to one object. So now let's understand what all components are there in this annotation file. For the so the first one is this one is object type, and in this case we have pedestrian, and this indicate the type of object annotated. And so guys, in this Kitti dataset the different objects are car, pedestrian, van, cyclist, truck, and then there is a miscellaneous class also, tram, person sitting, and don't cares. Okay, so these are the different 8 classes Kitti dataset is trained on. And this don't care class simply refers to a region of an image that contains objects which are not of interest for our specific task. Okay, so after that we have this 0.00. Now what it is? So this is truncation basically. So what it measures, the value is 0.00, and this truncation measures how much of the object is visible. The truncation is typically between 0 means fully visible, and 1 means not visible. So in our case it's 0, that means the object is fully visible. And then we have the next value, which is this 0. Occlusion. It indicates the level of occlusion of the object. So let's suppose over here we are having a 0 value, so that means the object is fully visible. And if over here we have 1, that means the object is partially occluded. And if we have 2 over here as a value, which means that the object is largely occluded, and 3 means unknown. Okay, so here you can have 0, 1, 2 or 3 value, and I've told you what all values, what every single value means. Okay, and then we have this minus 0.20. so this is the observation angle, 0.20. so the observation angle of the object, so this minus 0.20 is the observation angle of the object relative to the camera view. Okay, and then we have these 4 values as our bounding boxes. So guys, remember, so as I've told you, we are going to use YOLO-NAS model, and YOLO-NAS model is an object detection model, and we can perform other tasks also with the help of YOLO-NAS like image classification and segmentation. But for our today's class we are focusing on object detection. So for object detection we need a bounding box. Bounding box simply means a rectangular box around the object. So for that we need 4 coordinates. So this is the first coordinate, second, third and fourth. These are the 4 values. So these 4 values define the pixel coordinates of the bounding box surrounded the object in the image. So it is given by 4 values. First one is x min, and then we have y min, then we have x max, and the fourth one is y max. Okay, so these are the 4 values. After that we have these 3 values, 1.89, 0 point this and this. Now these 3 values tells us this is basically a 3D dimension of the object. Okay, 3D dimension means height, width and the length. So height over here is 1.89 meters, width over here is 0.48 meters, and then depth over here is the length over here is 1.20 meters. Okay, so then we have this. After that we have location, these values over here, these 3 values, first value, second and this third value. This tells the 3D location of the object in the camera coordinates, so which is right, down and forward, 3. Okay, so after that, and it is also in meters guys. After that we have this last value, which is 0.01. This 0.01 tells the rotation of the object around the y-axis, which is up in radians, and that's it guys. So this is in this Kitti dataset. Every annotation file will have these kinds of detail. You will have object type, then occlusion type, and then the movement, and the 3D dimension, 2D dimension, object bounding box, whether the object is occluded or not. So all these details you will get for each object. Okay, but Now the next thing is we have downloaded the data, right? So now once you download the data, our next task is to convert these annotations into the format which YOLO model accepts, right? So for our YOLO model, what things we need? We only need the class label and the bounding box. So we need this and these 4 values, okay? So apart from these things, bounding box coordinates and the class name, we don't need any other detail. So you have to write a script which will help you to have the annotations in the YOLO format. Now let me show you. I have converted these annotations into the YOLO format. Now let me show you that, okay? So guys, for that, let me open the folder in which I'm working. So I have a separate folder with this name, YOLO-NAS Kitti dataset. So inside this folder, I have a dataset folder. So guys, right now, please don't worry about the other folders. I'll tell you in some time what these folders are and why we are using these folders, okay? Just for now, just see that I have a folder with the name of dataset. Just create a folder with the name of dataset. Inside that folder here, remember this data object image 2 and data object label 2. These are the folders we have downloaded from the Kitti dataset. In my downloads folder I have shown you, right? Okay, let's go back to the downloads folder. You can see, so this folder and this folder, when we extracted them, we got these 2 folders. So these are the 2 folders which I have pasted inside that dataset folder, okay? All right. So once you have that, and now let's open this image folder. So guys, training and testing folders we already had from the Kitti website. Now what I have done is I have created a separate folder with the name of validation, and from training images, see, earlier if you remember in the downloads, let's go back to the download and go back to the image folder, open it and go to this training and image 2. Here you can see we have 7418 images. So what I have done is I have splitted this data into 2 parts. One I have used for training and the other one I have used for validation. So I just took 481 images from this training dataset, and I have created a separate folder with the name of validation, and I have pasted these 481 images in that, okay? So that's what I have done over here, okay? So created this validation folder, and here I have pasted those 480 images here, okay? Now in the same way, now let's go to this label folder. In the same way, now guys, over here I have the annotations which are in the YOLO format. I have converted the annotations now, because what we want for YOLO algorithm, we need the class name and the bounding box coordinates. So I have that over here. Train labels, in the same way I have created another folder with the name of validation labels, and in this val labels I have pasted the annotations file which are related to those 480 images which we have pasted just in the validation folder, okay? So let's open it, and you can see we have 480 annotations in it, and in train labels we have 7001 annotations over here. Now let's open the very first annotation file and see. Now you can see these are the bounding box coordinates, and this one is the class ID of the pedestrian object, okay? And now our data set is in YOLO format. Now we can use the algorithm on it, okay? So now let's come over here. So guys, here you can see this Jupyter notebook. This is the Jupyter notebook in which I have written the code to train our model, save the trained weights, and then to make predictions. Now guys, if you want to run this code on Google Colab, I'll show you the steps first, how to perform this training on Google Colab, okay? And after that I will show you how to work it on a local computer. Now let me open the Google Colab notebook first and show you what I have done over there. So let's go here, and this is the my Google Drive, and in my Google Drive I have created this folder And in this folder you can see this is the Jupyter notebook I'm talking about, where I've done all the training and rest of the part. And this is the dataset folder. This is the same dataset folder which I have just explained you. You can open it and see. Inside this label you will have labels for training and validations, and inside the images you will have training, validation and test images. Okay, so your data set should be over here like this. This is a data set and this is a code. Okay, now let's open this this notebook and see. So guys, first thing is if you're working on a Google Colab notebook, so you have to select the GPU first. And how you can do that, just go to edit, notebook setting, and from notebook setting under this hardware accelerator select this GPU and then save. Okay, after doing that you can run this command and you can see if GPU is being used by our notebook. Okay, Colab notebook. And here you can see this is the GPU we are using. And guys, same thing, if you want to see this GPU detail with the help of this PyTorch code, then you can run this import torch, and then if CUDA is available, get the name, and this you can see the GPU name is Tesla T4 and GPU is available. True means this notebook is using the GPU. Okay, so first, this is the first step. After that, in this line I am just mounting my Google Drive. Okay, and guys, after writing this in this line here, so here what I'm doing is I am just creating a symbolic link, so with the help of this is basically just a link. So instead of writing this whole thing every time whenever I want to provide the path of the Google Drive, I have created a link, which means is instead of writing this whole thing every time, I will just write my drive and the entire path of the drive will be given. Okay, will be used. So you can see in next line only. So CD, if I haven't created this link, then what I have to write over here, then I have to write this whole thing over here, and then we will and after that I will say that I want to enter in this folder. But now after creating this link, I'm just writing my drive, which means that I want to I'm writing this location only. Okay, this path only. So my drive, and then the folder in which our code is and our data set is. I have entered in that folder using this. Okay, now once you enter in the folder, now guys, to use this YOLO-NAS is very simple. You just need to install super gradients package, and you can install it like this: pip install super gradients. And once you install the super gradient package, okay, wait, after that install this imutils package also. That's it guys. Now your environment is ready. Okay, now you can train your model. Now first thing, whenever you want to train your model, the first thing is to define the trainer. So how we can define the trainer? So this is the cell, this is how you can define the trainer. First we are importing the trainer, then this checkpoint directory and this over here, experiment name. So guys, what it means is, it simply means that when we will start the training, after the training we want to save the trained model in this checkpoints folder. Okay, inside this checkpoint folder you will get another folder with this name, and inside this folder you want to save your trained weight, your last weight, best weight, all the logs, everything related to the training you want to save at this location. So you can change them, you can give any names over here. Okay, so this is the first thing. After that, now let's talk about the data sets and the data loaders. And guys, super gradient is fully compatible with PyTorch datasets and data loaders, so you can use your data loader as is. If you want to know more about these things, you can visit these links. If you want to learn more about working with super gradient datasets and data loaders and configuration files, you can check this link over here. Okay, so here I am defining the data loaders, I'm importing the data loaders. So after that, inside this dataset parameter, you have to provide the path of your training images and labels, validation images and labels, and then your classes. So these are the classes. So Kitti dataset have these classes: car, pedestrian, van, cyclist, truck, miscellaneous, tram, person sitting and road care. So guys, from here, from this cell, everything, if whether you are using a Google Colab notebook or you are working on your local computer, all the steps are same. So I am going to my Jupyter notebook, which is on my local computer, and I will show you the further steps on that. So here, so see, this is the trainer, and after that here we have defined the path. Here you can see the path of my training images, path of my training labels, and the path of the validation images, path of validation labels, and this is a list of classes which we have in Kitti dataset. Okay, so now let's create a data loader for training dataset and validation dataset. So for that, this code is for training dataset and this is for validation dataset. And you can see here inside this data directory, over here we are providing this value. What this value is, this is the dictionary we have defined above. From dataset parameters, we are taking dataset directory and we are providing it here. In the same way, train image directory, train validation directory. So we are providing all the values like this. So this is the train data loader and validation data loader. So after that, now let's start with the model. Let's pick the model we want to use, and we are not training a model from scratch. So what we'll do, we'll pick the pre-trained model. Okay, so there are YOLO-NAS have 3 different types of model. One is medium and then small and the large. So over here I'm using YOLO-NAS L. L means large model, and then here in number of classes we are providing the number of classes which we have in our dataset. And then pre-trained weights COCO means the YOLO-NAS model, large model which we are using, it is trained on COCO dataset. Okay, so inside our model variable we have our model. Now guys, now over here we have to define some training parameters. You can change these training parameters, okay, to see how your model work. When you change the parameters, you can fine tune the values. Okay, so for now, here you can see we have all the things. Optimizers you can define, and then learning rate and initial learning rate, warm-up epochs. Okay, so these kind of values are here. And there's one more thing to remember, that when you use this code over here, you have to set the number of classes in 2 places. One is over here inside this, see the number of classes. You have to define the classes here, and the other thing is you have to define the classes over here also. Now these are your training parameters which will be used when you'll start training the model. Now let's train the model. To train the model, you only need to call this trainer and trainer.train. Guys, remember this trainer, this was our first cell. Let's go up, and here you can see, here we have imported the trainer, and inside the trainer what we have written, that we want to save all the trainings inside a checkpoints folder. We want to have this folder, and in this folder we want to save all the logs and the trained models and any other file if it is there which is related to training a model. Everything should get saved in this. So let's go back here. Yeah, here. So model, we are providing the model. Which model is this? This is the model which we have defined here above, here, this model. Okay, so model we have defined, training parameters we have given, and this is the training data and then the validation data. So we have started the training. I have trained this model for 200 epochs. After training the model, you will get a checkpoints folder. Now let's go back to our code, and here you can see this checkpoints folder, right? So let's open this checkpoint folder. Under that you have this folder, and inside that here you can see all the files and the models which are related to the training. Here, this is the best model. This model we will use for making the predictions, and this is the latest model, this is the best model, this is the average model, and here are other files. You can see all these files and you can learn more about it. So this is how we can train a model. Now let's use this best trained model and make predictions. So for that I am importing the models first. and these are the classes we have. Okay, 8 classes, and here inside this best model variable I'm using this YOLO-NAS L model, the number of classes these, and then this is the weight. So from the checkpoints folder where we just saved our trained weights, so from there I am picking this best model, and I have a folder with the name of test images. From that folder I am picking this image and I want to make predictions on it using this method, and dot show will show you the output on the screen. Now let me show you the test images folder, what I have over here. Test images folder. So inside that folder I just pasted few images from images for testing. So that we have. Okay, this is how you can make predictions on single image. Now let's suppose you have a folder, and in that folder you have multiple images and you want to perform predictions on all those images. Then this is how you do. Write the name of that folder. You have to write the entire path. So in my case, my Jupyter notebook and this test images folder is in same directory, so that's why I've written the folder name only. But if your folder is at some other location, then you have to provide the path accordingly. So this is the folder which have images, and then I'm using the predict method on it, and then I want to see all the images with the detections which are there in that folder. So this is the first image, and this is the car detected. This is the second image, and this is the third image, fourth and fifth. Okay, now let's suppose if you want to test the video, then how you can do that. So I have two variables. This is my input video, this is the name of the input video, and this video is in test videos folder, and I want to save the output video with this name inside this folder, right? Then the model, to device, predict method, input video I have given. So I want to make predictions on this video, and then I want to save. For saved you can write dot save, and this is the file name with which I want to save the output. Okay, so now let's see the input video first, and then I'll show you the output video. So input video is in test underscore videos folder. So this is the input video. Okay, just give me a minute. So this is one of the input video. Now let's see the output video. So for that I am going to this output videos folder, and here 3 out. Here you can see the output. We are detecting the pedestrians, we are detecting cars and vans. Okay, so in the same way, if you want to see the output on some other videos, I'll show you that as well. Let's see the another example. So this time let's talk about this video. This is the input video. Let me open and show you first. Okay, so this is the video. Now on this video let's perform detection. So inside output video, this is the output. Okay, so guys, this is how you can use YOLO-NAS for object detection. So, and guys, if you want to know more about YOLO-NAS architecture, then you can visit this page. So I'll share this link in my description section. You can you can check this page. Okay, and if you want to, you can visit this Desi AI super gradients page over here, and here you can find different notebooks and tutorials, and you can learn more about the different data loaders and how you can work with your custom data sets in detail, and what all different parameters are there, and what all different things are there which you can do with YOLO-NAS. All those things you can check on this super gradients GitHub page. And guys, also you can check this super gradients page over here. So what is super gradient? This is a PyTorch based deep learning framework, open source framework, and using which YOLO-NAS has been trained. Okay, so you can learn more about it from here. And after that, there are other models like today we have discussed about only object detection, but with YOLO-NAS we can perform semantic segmentation, pose estimation, and image classification. You can try these models also. And in my upcoming videos I'll talk about, I will work on the semantic, pose estimation, and image classification models. But till then, if you want to try these models, you can try that. Okay, So I hope this video is helpful, and guys, the link of this code is given in description section. You can check that code, and I hope this video is helpful. And guys, if you like my video, please like, share and subscribe my channel. Thank you for watching.